Hello, folks. Welcome to Rational Science. And hopefully everybody had a great Christmas, Merry Christmas, and everybody has a Happy New Year. And hopefully next year will be even better. So for the new year, okay? So let's celebrate a little bit. Here's a little bit of champagne, okay? So to give me energy for today. Okay, so let's get started. Over the years, we've had people who have come and gone as subscribers and as people who supported the show. And I do thank all those people who, through Patreon, have supported the show. A lot of people, who came and went there as well. But I said a long time ago that as long as at least one person supports the program, I'm going to keep it open. And so far, they have not disappointed me. Anyways, a lot of people have come and gone over the years. And we're not a very popular show. Okay. And to some degree, that's pretty good. It shows that only intelligent people stick around and try to figure out what the show is about, what the theories that we propose here are about. And a lot of people don't stick around to learn what we're proposing, and they're missing out on a lot of stuff. They just say, "Oh, this is business as usual," which it ain't. Bill said the same thing as something maybe Walter Russell or Tesla or maybe Ayn Rand. No, if you thought that, then you thought wrong. This is a totally new theory here, totally new focus on what science is. Okay, we're changing science here. We're saying that what we've done for the last 10,000 years has not been science, partly because no one ever defined what science is in a rational manner. No one has defined what physics is in a rational manner, and no one has defined what philosophy is at all. And so a lot of people come here and they accuse me of doing philosophy when they don't have the slightest clue what philosophy is. They have this vague notion of what philosophy is supposed to be, what physics is supposed to be, what science is supposed to be. And a lot of that has to do with simply what they're regurgitating from what they learned in high school or college. It's not like they really thought about it and asked themselves questions or question this worldly wisdom. Okay? And so the problem is that people come here and they look at the show me one day and they say, he's doing philosophy and we don't do philosophy in science, and they just run away and they never learn anything. And then they go out there and they do some criticisms of me. And I'm going to talk a little bit about that today. It's probably going to be relatively short and hopefully sweet. Okay. But essentially, all these people, they have this notion of what science is, what physics is supposed to be, what philosophy is supposed to be. And they say, it's not worth my time. I'm going to listen to the people who do physics, the people who do science. And who do they go to? Well, they go to people like Sabine Hossenfelder or Neil Tyson or one of the... what's his name? Brian Greene or Brian Cox, one of the Bryans, right? And so, and they think they're getting their science shot for the week. And that's the story. That's what they do. They just go out there. You go to those sites, they get millions of hits. I don't get millions of hits for sure. There's a degree of shadow banning. I don't get, my channel doesn't get spread around, even though it's been here for many years. And how that works, I have no idea. But essentially, you end up being shadow banned. The word doesn't get around. And it's a shame, because people would come here and they would receive a different view of the universe. Doesn't mean they have to believe it, but at least they get a different view that they can compare against whatever they learned. And a lot of people just won't get a chance, because the show does not have the popularity that other shows have. So what do we propose here? What is it these people are against? It's really not what they're against, because as you will see today, not a single one mentioned what this site is about. It's like they have no idea what this site is about. They just say, oh, Bill's doing philosophy, and what he's saying out there is not worth listening to. That's essentially all they say. And so we have to show, at least as a minimum, what this site is about. Let me start there. Let me show you what it's about very quickly here, okay? This is what has been proposed over the years by these gentlemen who started it, more or less. You know, the electromagnetic wave started really in the 17th century. The wave nature started with Robert Hooke, mathematized later by Huygens, Christian Huygens. But then over the years, they came up with not the longitudinal waves, but they said, hey, you know, it's a transverse wave, and that's what it is until today. We have the electromagnetic transverse wave, and it looks like that. It's a bunch of vectors. The vectors comprise two fields, the electric and magnetic field, and the whole shebang comprises the what we call light, electromagnetism, okay? And so this is just mathematics. You know, they show this stuff and people think they're looking at something. No, you're looking at nothing. You're looking at an abstract concept. So you cannot give a physical interpretation using what you see in front of your eyes right now, okay? And so we come out there and we propose something different, which looks like this. It's the electromagnetic rope. And we're saying these people for at least 150 years, maybe 200 years, have been confusing a rope for that electromagnetic wave. And that's where the problem is. You know, the electromagnetic wave is not a physical object, it's an abstract concept. And what we're proposing is, for the first time, a physical object as a mediator of light. Not for the first time, because they have proposed particles in the past. By particles, right now I mean corpuscles, little balls, okay? That died with quantum. Quantum does not propose balls. They insinuate that that's what they propose. That's not what they propose. When you hear particle accelerator or a particle physicist, it's got nothing to do with particles. Okay? The word particle is very misleading. The word particle means something different in the minds of these people. They're doing numbers. They're doing values. They're doing values followed by units. And when they say we accelerate a particle, what they're saying, they're accelerating a ball of energy. And you're saying it's a ball. No, don't focus on the word ball. That's what they illustrate. What they are really talking about is the quantity, you know, the energy value of that ball. That's what they're looking at. And the same thing when they accelerate mass or when they accelerate charges, they're talking about numbers. So the modern notion of the word particle is very misleading. It's not the corpuscle. They illustrate it with balls. They're not balls at all. They're talking about numbers and values, okay? And what we're saying is, hey, we're going to replace all that with a rope, okay? And so that's the first issue. What does a rope do? Well, a rope binds two atoms, any two atoms in the universe. And this is more or less the comparison between what mathematical physics proposes and what we propose here. Here's the comparison, okay? What they're saying is that you have this atom, right? And the atom is a little ball in the center, and there's a tinier ball, much tinier ball called the electron that rolls around it, somewhere around the nucleus of the atom. Why it doesn't fall all the way to the nucleus of the atom when one is positive and the other one negative has never been explained. Actually, it was the source of quantum mechanics. It was the origin of quantum mechanics. They never explained that, even to this day. And then the other question is, why doesn't the bead fly away? Okay. In our case, we're saying, no, what these people have been mistaking all these years is really a membrane. The electron is a shell. It's a membrane. It's a that encapsulates the proton star. Okay, and what you see there is that's expanding and contracting is the quantum jump, which they think it's a little ball that's going back and forth between energy levels. That's not what we're saying the quantum jump is. We're saying the atom is simply expanding and contracting. And what it's doing really, it receives all these ropes that are connecting each one of the atoms that you see there with every atom in the universe. And one of the threads goes straight through the center of the atom. The other one rolls around. It goes around and forms the electron membrane, the balloon that encapsulates the proton star. And by expanding and contracting, what it does, it's torques the rope, which is made out of the same threads as the atom itself, and every atom is connected to every other atom. So what they're doing, all the atoms are simply expanding and contracting and torquing the rope. In other words, the atom is a little heart that is pumping torsion waves through this physical mediator. That's the proposal. A little different than a one-way electromagnetic wave used by quantum mechanics, right, which is an abstraction and which has to do with mathematics, with numbers. It's got nothing at all to do with physics. Okay, so that's the comparison. And because any two atoms in the universe are connected to are physically connected, any atom is connected to any other atom. They're all physically connected. You know, there's a rope, right, that connects any two atoms. If we take my two fists as the atoms, that's the basic model. Take any two atoms in the universe. We're talking about hydrogen atoms here. Okay? They're all connected, physically connected. Okay, and because they're connected, we can explain gravity. And here's just a real quick picture of gravity. Okay, so that you know what we're talking about. We're saying that if you have an asteroid coming towards the Earth, the farther away it is, all the ropes come together. All these mediators come together, okay, that connect any two atoms. In other words, any atom from the asteroid is connected to any atom on Earth. Okay, we didn't draw them all, just in case. All we want to see is what happens when the asteroid is very far away. What you see is that all the ropes come together. And when the asteroid approaches the Earth, all the ropes fan out. And that, what you see there, is the acceleration of gravity. Okay, the closer it gets, a question of distance, right? The ropes fan out and gravity increases. That's it. Okay, it's just as simple as that. And for those people who say, well, Bill, who says that all atoms are physically connected and that's the cause of gravity? Well, again, we put this gentleman, his name is Richard Muller. He's from Berkeley University, and he tells you in your face, every atom on Earth is pulling on every atom of you. You're also pulling on it. You're pulling on atoms right now on the other side of the Earth. And then he says the amazing thing about gravity is that it goes right through things. So if you're wondering why the ropes don't get tangled, well, there he tells you. Whatever theory you have to show that the atoms ropes, whatever mediators are there, they go through each other. If you don't have that in your theory, then your theory has some problem with it, okay? Because they have to go through each other, okay? That's the condition. And yeah, all theories, whether people know it or not, they have things going through things. In fact, a good example is in the quantum world, right, is the neutrino. Neutrinos, they like to say that they interact weakly with matter, meaning they don't interact at all. You know, most of the neutrinos are said to go right through the Earth. So yeah, they have little balls, whatever those are, these neutrino balls, and they go through every ball that makes up the Earth, every atom that goes right through the Earth. So yeah, every theory that you can imagine has objects going through objects, okay? And so people never question that because mathematics has this duality where they use concepts as objects to explain the physical part, and then they revert back to the concept, and they say, well, obviously concepts can go through concepts. You know, love can go through love, even though heart can't go through heart. Okay, so when they explain the physical part, they use the heart, and then you say, well, you're really talking about love, right? Yeah, of course. You know, and so that's when people don't even think about love going through love, and that's what they do. They use words such as field. They use words such as energy, mass. charge, and so all these, nobody questions whether, a field can go through a field or energy can go through energy, because everybody thinks of them as abstractions, as concepts. But the mathematician has just finished using it to give a physical interpretation of a phenomenon. Okay, and we're going to see that in some of the comments that people made. And yeah, so you have places like Quora, like YouTube, and Hubpages. There's several places out there, and people have criticized me more specifically, more than the theory, because they really talk very little, almost nothing about the theory. So the question is whether these people even understood what they were up against, what they were analyzing. It's like, they were just upset that, my talks or what I propose offends their religion, and that's all there is. It's just a question of a reaction, a knee jerk there, where they say, oh, you're offending my gods. You're saying space-time doesn't exist. You're saying that a particle can't be at two places at once. What are you saying, Bill? Yeah. Yeah, that's exactly the problem. The problem is that they dismiss some of these criticisms as being semantic, ontology, philosophy, metaphysics, and they just dismiss it as not being part of physics. Okay, so let's see what these people put out there. People asking, especially in Quora. I'm going to go through the Quora questions, and these are the questions that you will see in Quora. Okay, you can look them up. What do you think about Bill Gaede's rope hypothesis? And they ask for their opinion. Instead of or the answers are related to opinions and not to analysis of the rope itself. Okay, do they take Bill Gaede seriously? Well, that's a question of opinion again, and all these really have to do with opinion. Is Bill Gaede credible? Yeah, so, what do you think about him? What's your opinion? And do you agree with him? So all the questions have to do with opinions. And, you ask for opinions, what do you get? You get opinions. So instead of an analysis and saying, well, look, this is where it fails, this is where it's irrational, or this, or I don't agree with this part or whatever, his assumption is misconceived, whatever, they never talk about that, or very rarely, if anything at all. What they do is they simply say, oh, he's doing philosophy, he's doing semantics, he's doing ontology and metaphysics and who knows what. And they dismiss it primarily on that basis, and very few really get to tackle the theory. Okay, so here's one individual who answered some of those questions. Says, almost nobody has ever heard of Bill Gaede's critique. Yeah, I'm a famous nobody. I said that at the beginning. I have a vague idea what he's about. And the answer is no, he has no idea whatsoever. He didn't even take the time to figure out what the theory is about. And there he says in the next line, says, I can't tell, he can't tell because he hasn't really looked at the theory at all. So he said, he can't tell whether Gaede's rope is meant to be some new physics. Well, is it or not? I mean, is it new physics or not? If you don't understand that, how can you say that you're not going to even listen to it because it's not worth listening? Then why does he even take the trouble of answering? He goes out there and gives out all these opinions about it without knowing whether it's even new physics or whether it's any different than what we have out there. And he may mean it only as a colorful expression of his main point, that all physics boils down to relations. I don't know what he meant by that. Of course, mathematics boils down to relations. Physics is not about relations. Physics is about making mechanisms with, simulating mechanisms with physical objects. If he's, in other words, the causes, right? If he's only talking philosophy, I don't need it because I already know it. Okay, so he already knows everything about philosophy, even though the word philosophy has never been defined scientifically, right? So whoever studies philosophy doesn't have the slightest clue what he's studying at the university. Right now, if you go to the, Stanford Encyclopedia of Philosophy, you won't find the definition of the word philosophy. And what everybody out there has essentially is, that it's love of wisdom, which is essentially what you get out of Plato's books. And so if you studied 10 years at the university, what did you study? Love of wisdom? Is that what you got your PhD in? Love of wisdom? And so he says, if he thinks he presented real physics, no one should read it. Yeah, so he doesn't know what it is, and he's just guessing. And he says, don't read it, because if he thinks he's doing real physics, then it ain't true. But how does he know it's true or right or rational or, whatever, if he hasn't even read it? He hasn't taken the trouble to see it. In fact, another fellow, and this is in another site, not Quora, but he says the following. He says, make the roast metaphorical rather than literal. And so he says, they should not be literal ropes. And he's talking about consciousness and who knows what. Okay, so he says, we're united by consciousness, and who knows what these people have in their mind. No. Let's make sure we're talking about a real rope. Now, it's not a rope that you buy at the hardware store. All we're saying is a physical entity that has 2 strands, 2 threads, 2 wires, 2, threads, any word that you want to put in there, 2 strings, right? And they're wound around each other like DNA. Okay, that's what we're saying is the mediator of light. Okay, that's all it is. It's very simple. Now, does it have the same property as the rope that you buy at the hardware store? No, it doesn't. Okay, it's got different properties. All we're saying, the architecture, the structure of the rope is like one that you would buy at the hardware store. That's what it would look like if you had the eyes of God. You would look at this thing uniting 2 atoms, and that's what you would see. One string, 1 thread, 1 wire wound around the other. Okay, 1 fiber. Okay, what does another fellow answer out there for all these questions? He says the following. He says, Bill believes that quantum theory is wrong. Absolutely not. Quantum theory is not wrong. Quantum theory is an explanation in physics, in science. Quantum theory is irrational. That's what it is. It's not wrong, or like some people like to say, not even wrong. And what they never realize is when they're saying that it's not even wrong, they're saying that it's totally irrational. And that's what quantum theory is. That's what relativity theory is. And that's what string theory are. All 3 of them are not wrong. They're irrational. Let's get the words right. Okay, why are they irrational? Because they're using concepts as physical objects. That's why they're irrational. They're giving you a mechanism, a cause, and what they're using as the mediators are concepts, mathematical concepts. That is totally irrational. It's irrational objectively once we define the word rational, irrational, right? And primarily the definition is that an irrational theory is one that has concepts being used as objects. Okay, that's the primary one. Then the other one is that, or second one, important one there, is that they either used undefined words or words that are defined irrationally, or that they're using these words inconsistently throughout the theory. They use several definitions. And in science, there's only one. Okay, so for any word, right? Okay, so it says, because it does not describe subatomic particles as objects with shape and size, and the media that allow them to interact as real substances. He claims this is reification. Exactly, that's the problem. And he says the fallacy of treating concepts such as fields and wave-like particles as real objects. Exactly, that's the problem. And there you see it on the side, some examples that I put out there off the top of my head. Excited field, transfer energy, carry a force or an interaction, move a mass. How do you move a mass? I mean, what are you moving, kilograms? Kilograms is a value. You don't move values in science, let alone in physics. Bend time, warp time, what is that? How do you warp time? Wave the wave, they shake the wave, right? Fall into a singularity, like, a black hole singularity, or begin the universe with a singularity, whatever that is, because as soon as you get to the singularity, trying to figure out what it is, they say, well, the laws of physics break down at the singularity. So you never get an idea what the singularity is. It's just a place where everything falls and never really gets there. Tries to get there, but never falls. Drag space-time, gravity probe B supposedly proved, this NASA, professional institution, says that they drag space-time around the Earth. This is what they proved with almost $1 billion project there, the gravity probe B. And so, yeah, it is reification, and reification is irrational in science. Okay, so I don't know what his complaint is, but there he says he has resurrected medieval celestial mechanics. Fellow says, personally, I'm comfortable with the awareness that the model is not the reality. So if the model is not the reality, what was the point of doing all that math, all those equations, right? If the model is not the reality, does not reflect what our universe is or how it works. And he says it's only useful insofar as it can predict real-world outcomes. So he's saying, I have an equation that says the car is running 50 miles per hour in a straight line, so I can predict that in 1 hour it'll be 50 miles away at such and such point. So he's saying he can predict. So what? Is that science? The fact that you can predict that a car will be 50 miles away in 1 hour because it's running at a constant speed of 50 miles per hour? Is that what science is? Okay. That sounds like good for technology, not for science. Science is about explaining something, not about describing and saying it'll be, I can predict where it's going to be, or I can predict that tomorrow there's going to be an eclipse of the moon. Yeah, you know it because you've seen it happen 1,000 times, so now you can predict because you measured and say it's going to happen, right? That doesn't mean a person can explain why there's an eclipse. The why would be we don't need any numbers. We don't need to make any predictions. All we need to say is, look, there's the moon is in front of the sun, and it's blocking out the sun. That's the explanation for that. That would be the explanation. That's what belongs to physics. But to say that at 2 o'clock tomorrow there's going to be an eclipse because you predicted it, that's not science. That's got to do with mathematics and has nothing at all to do with physics. Okay, the quantum world is outside the range of our natural senses. Yeah, so they say because they're outside of our senses, we shouldn't even bother trying to figure it out, okay? Because everything's done through experiment, measurement, observation, and since we can't observe or measure very well in there, so it's outside our natural senses, so don't worry about the reality. It never crossed this fellow's mind that, that you can imagine, you can try to visualize what's happening in that world and try to make sense of it. It never crossed his mind. He would think that's an opinion. No, it's called a theory. The opinion is when you believe in it. But you can come up with a theory and say, look, this is what I think is happening in that world. That's not a belief. It's called a theory, an explanation. The person's giving you a mechanism. And he doesn't seem to understand that. And you can see that in the next line. Therefore, we have no real choice but what? To describe. No, science is not about describing. Anybody can describe a chair. He hasn't done science. You have to explain. Okay, and so that's the problem. The problem is all these people do descriptions. Why? Because that's all that math can do. That's why they talk about descriptions. Math has no power to explain. That's why so-called science, so-called mathematical physics, right, has evolved to be descriptions, mathematical descriptions, and no explanation at all. Or better yet, irrational explanations. Okay, in conceptual terms based on indirect what? Observations. Yeah, they don't observe because they talk about observation, and that word observation is very misleading. They cannot observe anything at the subatomic level, okay, for example. And we cannot observe things out there like in the galaxies, the invisible mediators. You cannot observe those. But they use the word observation like bringing proof into, like the witness, I observed, so they bring it in as a weapon, and they use that as a weapon against you because they say, look, I observed particles. Now, you did not observe particles. We don't have particles mediating light, but they say we observed. And no, what they're talking about, they're saying they're going to simulate it with particles, and they call that simulation an observation. That's where the problem is, okay? And it says it is quite foolish to insist on physical descriptions of things outside our experience. And yeah, this is the problem. The problem is these people aren't even looking, a lot of them, not even looking for explanations because they say it's outside our senses. We'll never figure it out, so... so what's the purpose of continuing? I mean, are we just going to measure and create technology and call that science? Is that what it's all about? And we're never going to find out what gravity is, what light is, what magnetism is. We're not going to figure any of those out. It's just descriptions. I can describe how strongly one magnet attracts another. I can tell you how fast light travels. I can tell you how much force gravity has on the moon. You know, is that what it's all about? Just measuring and giving you a description? Is that what science is? You know, measurement is no big deal. I can measure a table, you know, and say it's 1 meter. The other guy says, I measured it better than you, Bill. It's 1 meter and 1 micrometer because I have a better, you know, measuring stick or whatever. So does that make you a scientist because you measured a table? You know, so this is the issue. The issue is all these people are just doing measurements and not observations. They call them observations, but they're not doing observations like, you know, with 2 eyes. And so we have a problem there. And here we have another guy who is on the same bandwagon as the previous guy. He says, it's clearly just semantical analysis of the language. So they think what I'm doing is just semantics. Okay, I'm just playing around with words. It's a word salad. As far as that's all they hear in their ears is noise. Okay, that's all. Bill, you're just making a lot of noise and you're not saying anything. They're not listening. They're not listening to, you know, what's happening. What's happening is that these people have irrational explanations and they dismiss those as, well, we'll never figure it out anyway, so who cares about rational explanations? But if you don't care about rational explanations, what's the purpose of physics? What are we doing? What's all this work? What are we spending millions in research for if they're not telling us, you know, what they get in conclusion? We haven't even figured out gravity. Not we, but I mean, the mathematical physicists have not figured out gravity in the last 10,000 years. They still don't have an idea what gravity is. And yet here they are, they're saying, you know, we don't understand and we'll never figure it out, but let's continue. And meanwhile, you know, people who criticize them, oh, they're just doing semantics. Okay. And so he says his main point is anti-reification. Yeah, they're reifying all these concepts that I mentioned earlier. For instance, he'd say energy is not a thing, but a concept defined in terms of things. His complaint is that physicists treat energy as a real thing. Yeah, that is one of my complaints, of course. You're using energy, you're saying you're going to transfer energy. You can't do that, not in science, not if you're going to give a physical interpretation. But he says physicists will continue to think of energy as a real existing. So he thinks it's okay for them to say that, for so-called physicists, you know, mathematical physicists, to say that it's a real thing. But he says, but any sensible person should agree that there's a distinction between these and physical objects. Yeah, there are. So how come they're saying that it's a real thing if there's a difference between one of these so-called things, which is really a concept, a mathematical concept and abstraction, and a true, real, genuine, you know, goodness, physical object? Is there a difference? Can I use a concept as an object? Is that what we're saying? We can use love instead of heart and say that love made the mountain move, love moves mountains, right? Is that okay to say that? If you want to say only the latter is real, a sensible physicist, a sensible one, right? One who senses, I guess, should basically shrug and get on with his work. So he should ignore any discussion on whether we're talking about whether energy is a real thing. A philosopher, however, will be happy to discuss it further, meaning that, a philosopher, he deals with energy. Is that what philosophy is all about? Dealing with words such as field and energy and mass? Is that what a philosopher does? So the question here is, what is a philosopher? What is a physicist? And these people seem to say that if you're going to do the qualitative stuff, we're going to shove that off to a philosopher, even though they haven't figured out what philosophy is all about. And if you're doing math, then we're going to call that physics, even though they haven't defined what physics is about. In fact, if you look up the word physics in some of the dictionaries and some of the encyclopedias, like the Wikipedia, it'll say that it's got to do with matter. Well, matter has nothing to do with math. Okay, so if it's about matter and objects, things, I don't know what math has anything to do with that. Okay? If you want to say only the latter is real, sensible physicists should shrug and get on with his work. A philosopher will be happy to discuss it further. Okay, so it has absolutely nothing to do with science as such, meaning science, he's equating that with mathematical physics and with math. That's what science is, just math. Okay? He doesn't dispute any actual results or theories. Yes, I do dispute the theories. The theories are the explanations. The explanations are all, without exception, irrational. Okay, so yes, I do dispute the theories or the math behind them. Well, the math is irrelevant because if you apply the math to the wrong object, the wrong invisible mediator, then your math is worthless. So it doesn't matter if you develop tons of math with respect to a black hole if there's no such thing as a black hole out there. It doesn't matter if you develop a lot of math with respect to dark matter and dark energy if there's no such thing as dark matter or dark energy. So what is all this math that they're developing? What is all that about? What's it giving us? What kind of information is it giving us if they're developing on inexistent stuff? I mean, they might as well apply it to unicorns, They don't exist either. His point is purely, philosophical semantical. Again, they're dismissing all this stuff as petty philosophy. They're saying Bill is doing just philosophy. That's not what we do in physics. Okay? That's essentially their argument. And here's another fellow who looks at that and he says the following. He says, it's not worth of any sort of considerations whatsoever because it is not formulated as what? A testable, quantifiable, predictive scientific model. What's Bill Gaede's solution? It is to argue that science is not and should not be about testable, quantifiable, predictive models. Yeah, because that's got nothing to do with science, right? Or with physics. So essentially this fellow is saying, if you don't give me some testable, meaning belief, because you're going to verify, you're going to be able to, confirm what I measured or whatever, measurement I've got, you're going to confirm it and run the same experiment and say, let's see if it's true what he measured or whatever. So he measures, and what does that tell us? Belief, testable means belief, that you're going to believe or not believe. Okay, it's just got to do with belief. So the word testable only means belief. Okay, it's got to do with convincing the jury. That's what testable, verifiable, falsifiable, all those mean the same thing. It means you're going to convince someone. And in science, we don't convince anyone. Okay, convincing, you do that out there in church. Okay, not in a scientific conference. Okay, science is about explaining objectively so the person understands the mechanism in the case of physics, right? Belief, verifiable, falsifiable, all this nonsense that Karl Popper invented, all that goes to the trash can. That's belief, that's religion. And it's got nothing to do with science. Quantifiable, well, that's only related to math. It's got nothing to do with physics. Physics is about physical interpretations, causes, mechanism. Quantifiable, that's math. We don't care about quantities. Predictive, we don't do astrology. We don't do predictions. Okay, so again, this fellow, he's got a PhD in what? Theoretical physics, or so he says. And that's what they brainwash him in. That's what he thinks physics is about. And so, yeah, that's the problem. The problem is these people just keep passing this notion from generation to generation. The new generation learns the same thing. It just regurgitates what they learned by rote in high school or college. And that's it. That's where we're at today. And here's another fellow, I'll say, around the same argument. Here's what Bill Gaede has to say about mathematics and physics. And this is from one of my videos, I guess. Mathematics has nothing to do with physics. Absolutely not. And physics is about explaining. Mathematics has nothing to do with science. In science, we do not use math. You say, Bill, what are you saying? What do you mean here? We don't use math in science? No, we don't. Because science is explanation and math is description. And descriptions are not science. In science, we do not just describe and say, oh, I saw the wall and it was white. Is that science? I saw the wall and found out it was, I observed. I observed the wall when I hit it, my nose, and it was white. Yeah, I mean, that's not science. Okay, the table is red, the chair is big, so many meters. No, that's not science. Science is explaining something. Science, that's what people want to understand. People want to know, why does this pencil, right? Let's see if I can get it right. Why does this pencil fall to the floor? That's what people want to understand. The cause. Why does it fall to the ceiling? That's science. But to say that, the pencil measures so many meters or centimeters, whatever, so many inches, and it flew at such and such speed, nobody cares about that. That's measurement. When you get a Nobel Prize for measuring that, anybody can measure that and verify, falsify, whatever. Okay, science is about explaining, not about describing. Okay, math is a descriptive language. It can only describe. That's why the mathematicians, since the 17th century, they said math is the language of science. Math is the language of physics, because all they could do was describe, and that's all they did for the last 400 years. Describe. That's it. That's what quantum mechanics is. That's what relativity is. String theory, they're all descriptions. In fact, even the electric universe, the flat earth, all they're doing is describing. Not one of them gives you an explanation, a physical interpretation. Okay? Especially, flat earth, what do they talk about? Density. You can't say density causes this, density causes that. Density is not a physical object. You have to put a physical object in there, and people don't understand that yet. You can't do physics without objects. You need to put a mediator, a physical mediator. If you don't, you're doing black magic. That's what you're doing. You're saying action at a distance. So you have to put physical mediators. It can tell you what the acceleration of gravity is, but it cannot explain to you what gravity is or how it does its magic exactly. And for this, there's only one way, and you have to figure out what invisible object is doing the mechanism. Right, that's it. And so he says this may be what he would like physics to be. No, this is what physics has been for the last 400 years, because they turned it into physics, the math, right? They turned math into physics. But this is not what it is, by the mathematical physicists who run the show, okay, who have usurped the reins of physics. That's where the problem is. Or at least not what it has been for the last few hundred years. Exactly. And that's the whole thing, that the mathematicians have taken over the guild, and they're the ones who call the shots. They have all the magazines, and they said, physics is math. And so when someone asks them, how does gravity work? Why does my pencil fall to the floor? And they say, well, we don't know that. We're still investigating. Someday we'll figure it out, or maybe we'll never figure it out, because all they're doing is measuring and telling you how fast it falls, what the acceleration of gravity is, or whatever. And so why are we asking these people questions that are not part of their, job descriptions? Why are we asking them? Why are they telling us? Because they spend 2 hours giving you physical interpretations on a lot of their shows. And at the end of the show, it's, you've never seen a single equation. And when they ask them, in their interviews or in their documentaries, what is gravity? They say, well, that I can't tell you. We're still investigating. In fact, we've got here several cases. But okay, so this is a summary of the objections that these people raised. Okay, Bill says that reification semantics. Yeah, that's what mathematical physics is all about. Quantum mechanics, relativity, string theory, it's just reification. Okay, in fact, in the case of string theory, they have this thing called a line. They call them strings. It's got nothing to do with strings. These are all misnomers. These are all misleading names, misleading words, right? They're doing semantics because they're saying a string, and it's not a string. They're talking about a line. What is a line? A line is an itinerary in the religion of geometry. Okay, geometry is a religion because they're doing geometry without objects, and it was supposed to be figures. About figures first and foremost. They're not talking about figures. They're not talking about figures when they talk about a zero-dimensional point. They're not talking about figures when they're talking about a one-dimensional line. What they're talking about in the first case is location. In the second place, they're talking about an itinerary. And they turn those into geometric figures. Why? Because they're going to be measuring. They're going to be unrolling the measuring tape along the cube, along the square, or whatever. And they're going to say, well, there's so many meters here, so many meters here, and here's the relation. So that's why the so-called line is really an itinerary. And so they screw it even worse when they say it's one-dimensional. No, it's not one-dimensional. There's no one-dimensional object. There's no one-dimensional all by itself. The dimensions are always three. Okay, it's the length, width, and height. And you can have two of those. You can deal with two of them, like if you're going to do with squares or circles. But there's always understood that in the background you have a three-dimensional object. Okay, so the circle is part of a ball, and the square is part of a cube, and etc. Triangle part of a cone, and so on. Okay, but see, these people say I'm doing semantics, that I'm accusing them of reification. Yeah, that's what they're doing, because you have to understand the language. And one of the reasons they can't convert math into qualitative explanations, why? Well, I'll tell you why. Because math has nothing to do with qualitative explanation. You cannot represent math with regular language when you're going to give a physical interpretation for the mathematical equation. You can't do that. It's like trying to translate, I don't know, Klingon language to English or whatever. You can't do that. They're irreconcilable languages. They have different purposes. Okay, our language, everyday language, is language of qualitative notions, and the language of physics really is objects. Okay, is illustration. You have to illustrate a mechanism. Math has nothing to do with any of that. Math is just quantifiable relations. That's it. Okay. Okay, it doesn't dispute theories. Wrong. I do dispute theories, and QM is not wrong. QM is irrational. Of course, QM model is not reality. That's what they're saying, okay, or that I'm accusing them, and they accept that. They say, yeah, it's not reality, Bill. So what are these people doing if it's not reality? But neither is Bill's rope. Well, yeah, this is reality. This is something real, okay? And for that, you have to define the word real, the word exist, okay? Yeah, we're saying that an object exists if it has location, okay? And so he would have to define reality or the word exist in order to make that sentence valid, okay? Foolish to insist on physical interpretation since they are outside our reality. That's what they're saying. We don't do physical interpretations. We don't care how this universe works. That's what they're saying. So can we introduce God then? He doesn't matter. He doesn't mind. He doesn't care. We'll bring God into the picture, the angels, the spirits. We can bring them all back in, Why not? I mean, I don't see if he doesn't care. I mean, they're giving him an irrational physical interpretation. He doesn't understand it. The people who created this didn't understand it, and they were forthright about it. They said, we don't understand it. And it's like, he doesn't care about that. He says, let's just keep doing math. So you tell me. Bill says that sciences should not be testable, quantifiable, predictable. Right. It has nothing to do with any of those. We don't test anything. We don't try to convince people, twist their arms. It's not quantifiable because that's a description. We need an explanation of the mechanism. That's what people want to understand. In fact, that's what people understand for physics. What is physics? We're trying to explain something. How does this universe, what is it? That's what we're trying to understand. And math cannot help us there. An equation will not tell us what it is, and an equation cannot tell us why, the causes. That's the issue. And so math has nothing to do with science or with physics, which is the next point there. And then without math, you can't measure accurately or make predictions. No kidding. Yeah, we don't care about that because measuring accurately and making predictions are not part of science. Those are not activities we do in science. In science, we only explain. Physics, we explain causes and mechanisms. In philosophy, we explain behaviors. And that's where those are the provinces of each one of those categories, subcategories of science. Okay, and so is it true that physics does not do explanations? Okay, qualitative explanation. And so here you have good old Feynman. I've brought him up a couple times, so let's have him speak for us. He was a Nobel Prize in 1965, I think it was. And he says the thing. He says the following. He says, "I think I can safely say that nobody understands quantum mechanics. Nobody understands it. Why is he trying to understand it if it's got nothing to do with mathematical physics, which is only about equations? Why is he trying to understand it? It says, do not keep asking yourself if you can possibly avoid it. How can it be like that? Why is he asking, how can it be like that if that's not part of his job description? It's not part of his line of work. Nobody knows how it can be like that. The more you see how strangely nature behaves, the harder it is to make a model that explains how even the simplest phenomena actually work. Why is he trying to make a model of how things work if that's not part of his job description? He should be doing measurement and equations. Why is he trying to give me a physical interpretation if it's not part of his line of work? And then he says, so theoretical physics has given up on that. Meaning, it used to be part of physics, or theoretical physics. It used to be that, they wanted to know how the universe works. And he's saying the mathematicians, they couldn't figure it out, and they finally gave up on that. We can't figure this out. So it's like, you got to see the magician on stage, right? And he cuts the lady in half, okay? So he cuts the lady in half. You ask him, and then she comes out, curtains closed, curtains open. She comes out, ta-da, she's in one piece. And you just saw her being cut in half with the blood dripping and all that stuff, right? And so you ask the mathematician next to you, how did that happen? And he said, well, the saw went at 2 miles per hour, and he gives you all these numbers. The lady was in 2 pieces, and she came up as 1 piece. It took only 10 minutes. That's not what I wanted to know. I want to know how you did the trick. And so there's a difference between just describing what happened and someone explaining how the trick was done. Those are 2 different things. And these people don't seem to understand the difference. And when they do, they say, well, we don't try to figure out how the magician did the trick. What we do is just measure and say, this is how fast he did it. This is how much time it took. This is how many pieces there were of the girl. Or maybe in this universe, in another universe, she wasn't cut. And they come up with all this idiocy. And everybody just says, yeah, that's good. It's just it. It's like you're dealing with zombies, right? And so here, just in case, you have this fellow, his name was Max Born, also a Nobel Prize winner, and he says the following. So, since the development of special relativity, theories using substantial ether fell out of use in modern physics, what they call modern physics, right? And were replaced by more abstract models. Quantum mechanics, general relativity, just abstractions. And what does he mean by abstract models? Well, they're using mathematical concepts as physical objects. That's what that means, okay? That's what they did. They had been using it for hundreds of years, and with quantum mechanics, it just went worse, okay? I am now convinced that theoretical physics is actually philosophy, meaning the physical interpretations, because they were done with abstract mathematical concepts. He said, hey, that's philosophy. And so all these people are doing philosophy, and the question is, well, do they have degrees in philosophy? Are they experts in philosophy? What right do they have to tell us how this universe works if they don't do qualitative physical interpretations, and they're just supposed to do math and measurement and, equations? So why are they crossing the line into physics, calling themselves mathematical physics or physicists, when they don't know anything about physics, when they don't know anything about what they call philosophy? That's the issue. And then again, we have a good old James Beecham, just in case. So not all of these people agree, and this is what he has to say. And listen to him carefully, but he's going to tell you that physics is about physical interpretations. At least that's what a physicist wants to know. Here goes.
What causes gravity? So physics, as you know, this is the type of question, what causes gravity? This is the type of question that keeps physicists up at night. Because physics is, among other things, as you know, the search for mechanisms, the reasons or explanations for why certain things happen the way they do.
So, is physics about physical interpretations or not? Some say it ain't, some say it is. And so we don't have a definition of physics. Obviously, if these people went through the university, they got their PhDs, and they all come up with different ideas of what physics is. Some say it's got nothing to do with physical interpretations. Others say that it is. Those are completely contrary notions, then these people have no idea what physics is about. They have not resolved that issue here in this day and age. Okay? And of course, you have good old Neil. I've presented him in the past, but I'm going to put him up again because it's good to hear what all these so-called PhDs that are now celebrities, what they're teaching or spreading, right, through their shows. And here's Neil. He's going to tell us what gravity is. I mean, we should know what gravity is after 10,000 years of dealing with gravity. Okay, let's see what he tells us. And here it is. Listen to him.
On his program Star Talk, mathematical physicist Neil Tyson was asked, "What is gravity?" This is what he replied.
We can describe gravity. We can say what it does to other things. We can measure it, predict with it. But when you start asking, like, what it is, I don't know.
Oh, that was great. He told us exactly what gravity is, that he doesn't know. I mean, here we are, thousands of years of dealing with gravity, and he has no idea what it is. And will he ever know, is the question. Well, how can he possibly know if these people are saying that that's not part of their job description, that what physics, what they call physics, is just equations. It's just numbers, measurement. It's got nothing to do with physical interpretations. Why is he answering the question, first of all? He's not supposed to answer the question because it's not his line of work. But then he says he doesn't know. That's a great answer. So are they doing physical interpretations or not? I mean, why is he even giving it a try? He should say, well, we don't do that kind of work. That's what he should have answered. But that's not what he answered. He says, I don't know. And then here he tells us what it is. And when they ask him further questions, he said, we're still investigating. So listen to him here. So we kind of round out what he really is trying to say, or what where the contradictions in mathematical physics are, or all these people who vouch for mathematical physics. Here it is. Listen to him.
Science can describe how gravity works, but can they describe why it works? So this is the how-why duality here. In science, if we can describe how something works and predict its future behavior, we claim to understand it and we move on. I can describe what gravity is doing. I even have a mechanism for it. Gravity really is the curvature of space and time. Why does matter and energy curve the fabric of space and time? And I don't have an answer for that. Why does matter and energy curve space and time? Okay, that's a frontier. We're still working on that.
Working on that? They're not working on that at all, because they're telling you that it's not in their line of business. It's not in their job description. So how can they be working on that if mathematics is never going to tell you what gravity is? So again, is figuring out what gravity is, how it works, what the cause of gravity is that part of physics or not? And these people say, on the one hand, yes, it is, and we're still investigating. We haven't reached there yet. We're trying to figure it out. And on the other hand, you have all these people who say, no, that's not part of physics. What we do is math. We do measurement. That's it. We don't care about how this universe works. And we'll never figure it out anyways, because it's beyond our senses, our experience, whatever. So what is physics? And hopefully next year we'll be able to answer that question. The problem right now is that all these people do not agree on what physics is. And so when I attack some people and say, look, you're using all these concepts as physical objects to get through your physical interpretations, they say, Bill, you're doing a semantic, you're doing ontology, metaphysics. That's not part of physics. Physics is equations, numbers, measurement, predictions. And so if that's what physics is, and that's what all these people study, and this is what all these people teach through their programs and interviews and documentaries, if that's all that physics is about, why are they answering the questions? First of all, why are we asking them the questions? And why, after they say, well, we don't know, we're still investigating, why are they saying they're investigating something that is not part of their job description? So we have dualities, paradoxes everywhere. And they absolutely love them, the mathematician. They love all these paradoxes, okay? So it's interesting, someone sent the note, and he says the following. He says, what I find truly incredible is the almost unanimous defense of such aberrations by the scientific community. People who study physics or mathematics are supposed to be very intelligent. Tell me about it. So how can we explain the fascination they have with these precepts? Could it be a general failure of the world's educational system? Yeah, partly it is the fact that we pass on from generation to generation the same notions and nobody is challenging them. Partly because they say if you challenge them, you don't get a job, you get kicked out. So if you want to belong to, to the club, you had better fall in line, right? And so how is it possible for Einstein's theory of general relativity to remain alive if the author does not define what time is? Yeah, they don't have to this day, they don't have a definition of the word time. And here they talk about bending time. What does that mean? Should it have been automatically rejected for not having the required basis, meaning definitions, right? The truth is that modern physics is in a hole from which it will be difficult to get out. And I would say not difficult, I'll say it's impossible because we have the wrong people answering the right questions or the rational questions that a rational individual asks are, tell me why a pencil falls to the floor and not to the ceiling. That's a rational question. Answer that question. And we're asking the wrong people because these people, some of them say, we don't do that kind of work. And the others say, we're still researching, but we haven't found the answer. And it turns out they're doing equations, and equations not going to tell them what physical object is in that region where they can't see or touch. Obviously, if this is falling down, right, and between the pencil and the earth, what did Muller say? Every atom in this pencil is bound to every atom on earth. So you have all this crisscrossing of all these mediators, and I'm going to pass my hand right through them, right? See? That means I'm going right through these mediators, and there's better be some physical mediators binding every atom of the pencil to every atom on Earth, because that's the only way an atom can pull on another atom, right? Then the only way to figure this out, which would be extremely simple, baby stuff, kindergarten stuff, is to visualize what physical objects, right, are mediating or are binding, right, connecting every atom of the pencil to every atom on Earth. One atom here is connected to every atom on Earth, and one atom of the earth is connected to every atom that makes up this pencil. That's what it is. That's what the Newton's equation says. And Newton's equation is pretty accurate. They say general relativity is a little more accurate, but general relativity has a different notion of what Newton had. In other words, if you look at the field equation, Einstein field equation, what it does, it takes a planet like the classical case of Mercury. They take the mass, right? They don't deal with objects. They squish the whole mass of Mercury into a single point, and then they have the itinerary of that point around the sun, right? And because it has all this mass, it weighs down space-time, bends space-time like a trampoline, and because it weighs down space-time, space-time distorts and then affects the movement of the point particle, the point mass, right? And so that's what his equations say. That's not what Newton had. Newton had something totally different, what's used by NASA every day. They brushed off Einstein completely. It's too difficult for them. They just use Newton, and that's how they send all the rockets out there. So we know Newton works, at least in the region here in the solar system. It's good enough for that. And so if Newton's equation, according to Muller, says that every atom on Earth is connected to every atom of the pencil, and every atom of the pencil connected to every atom on Earth. One pulls on the other. The only way you can pull it with some physical mediator. If you don't put a physical mediator, you're doing what is known in sciences and mathematical physics as action at a distance, which is the scientific term for witchcraft, okay? Voodoo physics. You pinch the doll and the guy gets hurt over there. So yeah, if you're going to do action at a distance, you're doing black magic. You're doing witchcraft, okay? And so you have to have a physical mediator. If you have a physical mediator, okay, we're passing our hands right through these physical mediators that bind every atom of the pencil to every atom on Earth, right? Okay, I'm going right through them. So your theory had better have objects going through objects, through mediators, physical mediators. Okay, that's the only way an atom can pull on another one. But of course, they never figured that out, and people like Neil and others, Sean Carroll and so on, even Sabine Hassenfelder, they'll never figure it out because they don't do physical interpretation. They're not figuring out what physical entities are in that invisible, untouchable world of gravity, of light, etc. They think they're going to figure it out through some kind of equation. And equations have nothing to do with the question being asked. So math has nothing to do with physics. And they haven't understood that. They think they're still trying to search for this holy grail. And the holy grail is this magical equation that will tie it all together. And it's got nothing to do with equations. Okay? Anyways, that's the story there. Once again, cheers for the new year, for all of you who support the show, okay, and Patreon, and for all the visitors there as well. Anyways, next week I'm starting the new year, and I have several things lined up which I think are going to be quite interesting. So all I can say is stay tuned. You're going to hear some interesting things in the next 2-3 weeks that might interest you, might be a good way to start the new year. Okay, so I'll have something to sell, maybe you too. Okay, so we'll see you next week. Next year, I'll see you next year. 1 year, I'll see you. Bye bye.